Welcome everyone. I'm G. Truglia, the president of TST.
And I'm Pete Meier of Motor Age Magazine. Thanks to everybody for coming out tonight for tonight's webcast. Tonight we're going to talk about a topic that G recently wrote about for us for the magazine, and that's testing ECMs, their inputs and outputs. You know, ECUs of any kind are not the cheapest thing in the world, and when you really think that one has failed and you get ready to pull the trigger on that part, it's an expensive part to replace. You want to make sure, number one, that that's what failed, but more importantly, G, you want to make sure you know why it failed in the first place.
Exactly, because that expensive fuse I call the computer, PCM, ECM, ECU, whatever you want to call it, very expensive. If you plug in and it's something that killed it, it's going to kill the new one.
Sure.
That's common in our industry, so be careful out there.
So I'm going to kind of like play straight man to G's lead as we go through this topic. But before we get into that, a little bit of homework for you. A lot of things going on at Motor Age with our training videos, of course, our webcasts with TST, other things that are happening. Just really don't want to type a lot of time tonight going through that. So I'm just going to say one thing to you. Log on to motorage.com/text. Sign up for the Certified Technician newsletter, and you'll be the first to know when our webcasts are coming up, when training videos are released, tech tips, news that's important for techs to know about, all delivered to your inbox. Don't forget, September we have another webcast coming up. That was going to be testing fuel systems, but using a scope. So that's going to be some interesting stuff that we'll cover there. All right, G.
Well, I want to talk about something before we get rolling as well. We're proud to be doing a big event out in the state of California, the Ontario Convention Center, where ASC, Automotive Service Council, used to have their big event. Well, we're going to be out there on September the 29th. So if you're in the California area, maybe you want to come out to see myself doing a P0420 seminar, as well as our buddy Dave Hobbs. Dave will be doing CAN diagnostics, and this gentleman right over here will be doing the keynote. So we'll have a bunch of people out there, a lot of our sponsors, Power Probe, OTC, Launch, Automotive Test Solutions, that's ATS, Smoke Wizard, not Wells, but the other, Airtex.
Airtex, yes.
So we will have all these people out there and then some, and hopefully we'll see you out there.
And ladies and gents, before you get too far on my way today, I got to tell you, it was my pleasure to go to the big event here on this side of the country. And if you haven't seen this is not your typical, sit down around the desk and watch the PowerPoint slides kind of an event. This is a really unique, interactive event. If you're in that area of the country, if you like what we do on the webcast, that's just a small taste. You got to go owe it to yourself to go check that out in person. So again, it's September 29th, right?
Yep, at the Ontario Convention Center. You can find that info on the website, or you can call us if you like. The other thing I'd like to say is, Pete, before we get started into this is a live event we're doing. We'll be with you for about an hour and a half. If you miss some of this, the great thing with Motor Age and TST, we put stuff up on YouTube. And thank you to YouTube, where you can go back and review. Now, with that being said, if you haven't been to YouTube, go there, type in TST seminars, you'll see all the different webcasts that we've done. So many of them that it's hard to remember which ones we did and didn't do. The next thing I'd like to say is this here. So what do you do when you can't communicate with ECM or PCM? In this case, that burnt one that I took out and took a picture of. These are problems that we deal with all the time. Now, most PCMs or ECUs or ECMs, I'm going to call them PCM from now on, they don't just decide to burn out. This is not the early days of 1980 when a whole bunch of GM cars did have issues. The mixed control solenoid click, click, click that we used to hear. Yeah, they had problems. Because an important thing to remember, low resistance electrically is going to equal high amperage, right? Or if we have any mechanical resistance, that could allow amperage to go up and cause a burn like this.
And the technology back in the early days of computers on the cars just wasn't there. They weren't built to design to handle the heat and cold, the vibration that they were putting up with. But then again, ones today are pretty darn good. I mean, back in the old days, you could pull the trigger on a computer pretty quick.
Like that.
But today, not so much. They don't fail as often. But that's what we're stressing here. If they did fail, there's a reason for it.
Exactly.
You got to find that reason.
Exactly. And now, let me also say this, since we're doing this live, I think I started saying that before, you know, not everything, just like in your shop, is going to work perfect. We hope everything goes smoothly. We're doing real stuff. We have a car behind us here, a 1996 car, because I had Neil bring it up, one of our TSD board members. I wanted to show you a special tool that GM used to use. And the reason for that is, I'm going to show you what that tool did was check all of the solenoids on the vehicle besides all the powers and grounds. Now, unfortunately, we don't have the right computer in this car. It's a late 96. That tool stopped in 1996. And I'm going to show you in a couple of minutes what I'm speaking about. Now, with that being said, you know, we'll be using things like a Power Probe, not because they're a sponsor. I've used Power Probe for years. Before that, fuse jumper leads. And if that's what you like to do, that's fine. You just need to remember, you got to go to All Data or Motologic or something, or good OE information, to make sure what you are applying power or ground to is really what you're supposed to apply power or ground to. If not, smoke show, okay? Now, sometimes you've checked everything on the car, Pete. I've been in this position for eons, right? You check everything, you're not sure it's a computer, and it's very, very expensive. Mr. Pierre over there, being our cameraman tonight, along with Doreen and Knock, you know, Pierre worked on BMW for years. And you're talking seat computers and many, many computers on board, up to 100 on some of these new 7 Series, just like that Audi A7 we have in the next bay. Guess what? A8, excuse me, A8. Thank you. A8. I got 7 on the brain. Anyway, even like that car, you know, how do you know when to buy that computer? You buy it off the dealer or a parts store, okay, you own it.
Right.
There is one great thing, but the reason why I'm thinking about this now, I always tell my students in the class, this is a website I want you to write down. It's www.ourecms.com. That's ourecms.com. RECMs.com. They're out of Pennsylvania, and I got to tell you, they saved a lot of my students' butts, and a couple of times, even mine.
Me too.
Check everything, and you hear Pierre said to him too, even on BMWs, you go, I don't know if I really want to pull it, but for about $100, they will overnight you a known good PCM or body control computer, whatever, and you plug it in. If it works, you got the option of buying it. If not, you can return it, and they're pretty good. And of course, they do check. Some people like to play games, because I've got a couple of guys telling me, hey, you know, the guy thought I changed the computer on him, but I got an old computer. So these guys are really good. They do a good job. I don't know if they ever watch these webcasts, but RECM's a place to go.
Yeah. And just real quick to interject, guys, something we failed to mention in the beginning, of course, like our other live webcasts, this is to help you and maybe make life easier in the bay. If there's something that you don't understand, put in the chat window, ask us to repeat it for you. If you have a question, feel free to ask anytime. We have Knock and Doreen over behind the controls there monitoring your chat. So if you have a question, be sure to ask it. You know, there's no such thing as one that you shouldn't ask.
Right, no such
Well,
thing as a
maybe,
stupid
but
question.
just, you know.
Well, they know if it's not an appropriate question, they're not answering. Okay, so let's move on here. A burnt out PCM equals its burnt fuse, right? If you simply replace that burnt fuse, well, what usually happens? It pops again. But fuses are cheap enough, right?
Right.
We're not going to take a chance here. So when you don't just replace this with a new one, what do? We're going to show you what to do tonight, okay? First of all, you're going to do the easiest things. Right here is the first thing we're going to do on a vehicle. And basically, whether you're going through this OTC Genesis tool, or in the case of this car, we're going to use the Tech 2, okay? We are going to activate the EGR valve, and we're going to check current draw to see if it's good or bad, okay? That way we'll know, hey, that solenoid is going to cause this computer to burn, or caused it to burn. If the computer is actually applying the ground, well, guess what? It probably ain't burnt, is it, right? Because the computer is like a switch. It is giving us the ground. Questions? None? Okay. Well, let me show you this first thing and get this out of the way. Pete, if you can be kind enough, maybe just to grab that and be my Vanna White for a second.
I'll be your Victor White. I think.
Oh, Victor White, okay. He doesn't want to go
No,
to Vanna. Okay, this here was the factory tool, and even though OTC, they made it for General Motors, had a little ribbon cable that went in the box, and if you read my article, I have that in the article. Back in 1980, you remember those days, well, the computer didn't have a lot of pins, right? They didn't have a lot of pins. Well, they went right up to 1996 to OBD2, and we could see the difference in the pins. Now, that being said, this was connected to this, and connected to that box.
So you kind of had a breakout box.
But better yet, you see this here? I don't know if Pierre can get in on that. It told us all the different things, the solenoids, and there's more on the cards. It would tell you the maximum amperage that you basically could have before it would go over. 600 milliamps on certain things, 300, 1200 would be, 1.2 amps would be a max. So this little box was really nice because look at this carefully. And if you want, Pete, you can put that down, so put it on the floor, get it out of your way, whatever you'd like to do. One of the nice things we had here is power on and off. We had all the powers. You see that? All the powers and all the grounds. So you know when we talk about doing voltage drop, I think that was our first webcast that we did with Motor Age, okay? It checks to see if you have good powers and grounds. Also, you can energize a circuit, okay? You can energize ground supply or feed supply. Most of ours, where the computer supplies ground, right? Certain times, like the old injectors that GM utilized on their car, did supply power like the Renix systems, okay? So they had
a lot of cars now
that do that. Oh,
they
yeah.
use the power supply.
They use the power.
Driver's side.
Well, how about all your training solenoids? They already have ground. Why am I going to apply ground and put power there? I can just put power through the computer. Up here in this window it would tell you how many milliamps. Once it got over 1200, that's 1.2 amps, 1 amp, 200 milliamps, this little light right here would come on, a red light. That would tell you short. And that's what that says. I don't know if Pierre can get in on that. I'll try to be steady.
There it is.
Okay, now, that being said, you're going, oh, we don't have that, who cares about that? And you'll notice this rotary dial had 23 positions. So it can do the 23 different solenoids that they had back then on their vehicles. So pretty neat. Now, I said, wow, this is great. And, you know, I love something like that, but guess what? How about if I'm working on a Mercedes or a BMW or a Toyota or, you know, a different car other than GM? Well, guess what? I need something like this, a power probe. Now, if you don't own a power probe that puts power, the red light on, and ground, okay? This is always ground. And one of the things we do to make sure we got good power and ground, we put it together. I see I got the light here. I press this and it should pop the 8 amp breaker. And you probably heard that little noise. That 8 amp breaker was blown, so now I can't put power on, right? I re-plug this in, now I have power and I have ground. Now the reason why I did that is many a times the ends of this, the red and the black, they have a poor connection. And if you don't pop that, now the ground or power you're checking may not be good.
Right.
Okay. So what we can do with this is we can do a couple of things actually. One, when a vehicle comes in with a computer that's blown, we can use our digital voltometer, take the ground, and put it to a good ground. Put the other lead right here in the amp clamp, and one good thing is if your fuse is not blown, which most people, their fuse is blown, Fluke does something here where if you put it in volts, you hear that beep? That beep is telling me my fuse is good, okay? And I put it in the 10 amp jack. I don't like this here. I know I have a newer Fluke that has the removable head. They did away with the milliamp 400 milliamp jack, which is good. I tell everyone, put a piece of tape over it because you're going to blow it. Now mine is not blown. But I can tell you, I was doing a class just a couple of weeks ago, and 2 of my meters, the guys blew the fuse. just because, and these are guys that are in the business. This is not school kids out
It's
there.
going to be just huge.
So now, once I know that, and we're going to make believe Pete's the ground, I have a good ground, I'm going to go to the solenoids that are in the car. And if I could see that that solenoid activates, I don't have an open circuit, do I? If I see I got more than 1.2 like this, I got 1 amp, 500 milliamps, well, guess what? That's what probably blew, not probably, that's what definitely burnt the computer out. One thing I'd like you to remember, you start pulling more than 1.2 amps, 1200 milliamps or more, on most vehicles that we're working on now, okay? There are exceptions with diesels and certain direct injection vehicles. But for the most part, what we're working on in today's shop, when you get over 1200 milliamps, you are going to burn out that computer component. That you have to go over about 6 milliseconds. So you got to remember, like, injectors come on at about 3 milliseconds, right? If you stay on too long, more than 6 milliseconds, it pulls more than 1.2 amps, you will burn the computer.
Make sure they know you have to test with the computer disconnected from the plug.
Ah, very good, Mr. Pierre.
Don't back probe it.
You cannot back probe it. This has to be off from the computer. Very good point. So did everyone get that? We pull the wiring off, key out of the ignition, pull this away, look at a wiring diagram, go in there, don't put the round peg in the square hole, use an appropriate setup to go in there, or you can back probe it with key pins from the back end, touch it, and then look at your current draw. If it goes over that 1.2 amps for more than 6 milliseconds, you boil.
I
Now,
like to ask you, aren't there some instances though where your computer is supplying the power to that
yes.
component as well? Now, if you disconnect that,
Oh, that's when you go to this. You jumped ahead of me. Very good. This man is too smart for me.
Well, before we get to that question, I just want to kind of reiterate for some of the people who are watching, essentially what you're doing, and you correct me if I'm not following you there, G, but what we're going to do is we're going to use the ammeter function of the meter as that driver and substitute the PCM driver to control that device.
Exactly.
And what we're looking for, and we stress here on that chart that G mentioned earlier, in the old days, everything was a ground side switch.
Right.
And you could do this and with some safety. But you have to look at the diagram today to make sure that the device you're testing, whether it's ground side or power side. Now if it's power side, we can still do the same thing, and I'm sure you'll address that. It's just a matter of where you have to place your leads to complete that circuit.
You have to apply power or ground with the power probe through the meter in order to get that test to work.
Yes.
Right? Because the meter's not generating the power or the ground. The meter's just the meter.
Well, the meter could do the ground. Let's take an example. I unplug this, key on engine off, and don't look at this transmission setup here. This is a transmission solenoid pack, but same idea. Let's say I pulled this off and I'm on the PCM. Key on engine off, I get 12 volts to my injectors, don't I? When I go to injector driver 1 and Pete's the ground, and I go here, make sure this light blue is the fuel injector 1, and I touch it, I'm going to get an amperage reading.
Yes.
Now, do not stay too long on those injectors. Why? We're going to hydrostatically lock it. So once I go like this and I get my reading, once I see I'm not more than 1.2 amps, crank the engine over. Get that fuel out. If you hear it go, oop, stop, take the plug out, disconnect fuel, and clear that cylinder out. And make sure you cut spark. Will be a flashback from that, right?
And
if you have a mustache or a beard like him, you no longer will have it. It will be burnt.
And really any solenoid, any coil, whether it's an evap solenoid or a primary side of the ignition coil or the injector solenoid, they're not designed to run on continuously.
Wow.
You want to make sure that, like as you pointed out, you just momentarily touch the contact to activate that device and get your current reading. And it only takes a millisecond. It takes very little time whatsoever. And we've talked about this before because we've a number of times for testing for a solenoid that was sticking or mechanically failing or shorting out once it got hot. It might be a good idea to repeat that test in the solenoid several times over. I'd say 20, 25 times, one after the other, to see if that changes as it starts heating up. Because that could also cause you a problem. It may not blow today, but
Right.
Guy travels across the state, and next thing you know, it pops open. I think we have a question there.
Yeah. If I have the room for it, is there any problem with me just using an amp clamp or on a cylinder?
Oh, well, we're going to address that. The question was, if I have room, can I use an amp clamp on a scope? Very good, because we're going to show you the first step, using an amp clamp on a scope and using our scan tool as we went back here.
Yeah, that's a great question, and we are going to cover multiple approaches for using what you happen to have in your toolbox.
Right. So the meter is the first thing you can use, but I'm lazy. And I would think, and I'm going to pull this out, by the way, when you're done using something so I don't make a mistake, out we go so I don't burn my meter out. And we just move this away and put it on this cart. We got some common solenoids here.
There's a question here.
All right. Let me just get this and we'll take the question. This common solenoid that we're going to check first, by using the scan tool, I'd like you to work smart and easy. You know, here, whether you have a snap-on, an OTC, or what I'm going to use right here is the Tech 2, okay, and a scope and an amp clamp hooked up. Okay, we're going to do that first after I answer this question, or Pete and I answer this question. Question, please.
Would you use known resistances if applicable to figure A and acceptable current draw?
Okay, now that's a good question. When I use certain resistances, you know, specifications. Now, most of these are 13 to 15 ohms of resistance. So the higher the resistance, GM used to have a little thing, 25 ohms, and you were safe, except for their peak and hold injectors that I think we should talk about. Peak and hold would have a half an ohm, very low, or 1 ohm, very low resistance. When it first came on, it would pull high amperage, somewhere about 4 to 5 amps. Now, someone out there is going to go, hold it, he just said more than 1.2 amps is going to burn it out. Yes. It took a peak and hold injector, went on like this for about a millisecond. There's 1,000 milliseconds to make 1 second, so it did it for about 1 millisecond,
If that.
and if that, and it went down to 900 milliamps on the hold. The hold is where that injector is actually making the pulse slip, the fuel going in. So they did that to overcome the fuel pressure and put in the fuel to that intake system.
And I would just kind of add one thing to that. You've heard me preach, and I know you've heard G preach, and anything he's done training on or written, and in previous webcasts. First and foremost, these are general guidelines to help you understand the type of things you need to look for in this particular situation.
Correct.
But you always, always, always go to the OE service information or good aftermarket service information source and read up on the procedure there. See what the specs from the manufacturer are. Yes, there's always going to be an exception. There's no such thing as a general rule of thumb in today's business anymore.
Here, can I borrow your ballpoint pen, please?
Certainly.
Thank you, sir. Okay, now let's say I had good resistance on this injector. There's a little pintle on this one, right? Similar to this ballpoint pen. Now, I can have perfect resistance, which tells me my windings in here to these two terminals are good. I have continuity, right? But how about if the pintle has carbon, or it bent, or something inside went bad? Mechanical resistance. What happens to amperage? Amperage goes up, we have a burnt computer. So resistance in that case wouldn't help. Resistance is a good place maybe for a quick check, but it's nothing like amperage. Amperage tells us the work that that solenoid is actually doing.
Sure.
Does that make sense to everyone out there? Is there any more questions? Okay. So Pete, did you want to say something else? Here you go.
We're all caught up on that point.
Okay, let's take a look here at the scan tool. And I don't know, Pierre, if you can follow me into the car first. And by the way, we should say that noise you hear, that little humming in the background, that is our Medtronic's battery maintainer over here. Okay, the GR8 we have on it. That is a battery charger, battery tester, or maintainer. Does a whole bunch of stuff so we can reprogram it. I have an amp clamp right here. I'm not going to pull it off because I have it on the right wire, okay? Or I guess I can pull it off. I will pull it off, how about that? We're using the ATS scope, and when I put this on, I want 1 MV equals 10 MA. Now, if you own other scopes like Snap-on or OTC or whatever other brand, Fluke, this is also 100 millivolts equals 1 amp. So you go on the voltage scale on your scope, okay, and you can set it up. Now on Bernie's scope, he has the presets right here where I'm saying 1 MV equals 10 MA. That way you don't have to worry about the clamp. I zero the clamp, and notice the little line. When I peak it, you can see the little ripples. You getting that here?
Yep.
Okay, now once I zero it, now I can put it back on this wire.
Be aware, Jerry, it might hang up on the...
I got it.
Okay.
I got it. The jaws of the amp clamp must be closed, right, Pete?
Absolutely.
I mean, Pete and I have done other stuff on lab scope and all that, but if you're not aware of that, your jaw's got to be clean. And I'll give you another caution. Those 9-volt batteries tend to be a bear. They start dipping down. They don't have 9 volts in them. They got 8 or a little less. You're going to get a bad reading or an erroneous reading, or none at all.
And 2 little side notes for you guys too. You can use that low amp clamp in conjunction with your DVOM if you don't own the scope. There's a lot of neat tests you can do with a low amp clamp in addition to the ones that G's going to show you tonight. And if you're a scope, what's the right word, aficionado? There are now milliamp clamps that are capable of reading down to very, very, very small amounts.
Yeah.
And of course, hang in with Motor Rage because we're going to have features on those topics coming up real soon.
Yeah, in fact, there's one clamp coming out from a company called General that not only does low amp stuff, but it'll do the high ones and give you the picture of it. And it can be hooked to a scope or go around it as a handheld. I'll show you one from, I think it's the Canadian company GTI that's pretty nice up in Canada that I'll pull out in a second to show you. Now, we have the Tech 2 hooked up here, and I'm going to go into engine output controls from the main menu. If I back out, let me just do this here. See where I'm at? I go in, I selected my car. I can go into trouble codes. I'm not really going to look in there. I'm going to go down to special functions. Once I'm in here, I'm going to go to engine output controls. And once I'm there, since I have my amp clamp on the suspected circuit, I'm going to EGR. I'm going to hit enter. Now, by the way, some of you are probably going to ask, could I do this on my OTC? Could I do it on my Snap-on? Most likely, especially on this year car. Okay, this was the factory tool and still the factory tool up to present on certain cars. Any canned vehicles, I got to use my GM MDI. Like on my Volt, that needs the MDI, so that's a little different. Okay, so here I got decrease or increase. Notice the screen back here, and I'm just going to move this down because we want to look at this line. We don't want to see anything over that 1 amp. We want less than 1.2 amps. So I'm going to increase this all the way I can. And I don't know if you can get that.
I'm zoomed in pretty good.
Okay, so now I got 20%, 30%. Up, the clamp's on upside down. So, Pete, you can play adjust the button. Oh, you want to do that?
For sure.
He's a nice guy. Where did I get him from? I don't know. Okay, so now Pete is adjusting it. There we go. We're back at, hit that 0 first on it, Pete. Okay, we're back at 0. You saw the spike there. It's zeroed out. And now we're going to do this. I'm going to increase it. You can see the hump right there go up. I'm going to go all the way I can. 100%. How much amperage, Pete, are we reading?
About 1 amp.
About 1 amp. You know that little thing on the 1.2? Now, I shouldn't be leaving it on this long, okay? Because the solenoid goes up and down momentarily. This does it on a duty cycle, doesn't it? So sometimes you even have things that are called a timeout. Okay, and I think this thing just did timeout. Let me leave it up there for 1 amp for a second. I'm at 100%. Most of these things will time out. That way you don't leave something on too long. Again, you're doing a fuel injector, well, guess what? Now I guess this one ain't gonna time too quick, so I don't want to over here. There it goes, without touching it. Okay, if you did that on a fuel injector, we would get hydrostatic lock, right? So, if you don't own a OTC, a Snap-on, a Tech 2, whatever you're working on, you don't have the scan tool capabilities, well, then you're going to need to do this with a power probe, right? So, Pete, if you can come over here, we're gonna see if we can get this baby clicking and licking over here.
No licking.
Let's see if I have another one of those baby ends. And we're gonna show you with our power probe, and we're gonna take that amp clamp off the car and bring it over here. So let me see if I have another small end. If not, which is Murphy's Law. Let's put this in one end. Put that in the other end. And we don't have continuity. So either that arm, this is too loose on that pin. You can go to the bottom. Go to the end pin. We'll have to try each pin to see when we have continuity. Either that or not in one of these. Try that again. Try the end pin. There we go. We got continuity. So if you can see, we can maybe just tilt that a little bit this way. I know it's a little tough.
I had it. Yeah, I got it.
Okay. So we have continuity, which is this solenoid is going to work. So if we're on it and we hit this, you hear that? But that's no good because I can't tell how much amperage I have. I could do this, right? We take our amp clamp, we re-zero it, we put it around the wire, hit the button, Pete. Is that going up or down? Am I
It sure
backwards?
is. You got it. No, you got it.
Okay, and how much amperage are we pulling there? Hold it on, Pete.
Looks like about 1.7 or 8. I can't read the...
Yeah, you can go in front of it. You get to see Pierre in his blindness. No,
There you go. I'm going to say 1.5 actually.
Okay, so hold that on again. I'm just going to take a look to confirm Pierre's good eyes. And I would say, yeah, you know what? Right here, 1.3. You can see it right here in the box.
Pierre's bad eyes.
1.3. That's okay. Now, we're holding this on. This was a defective valve for whatever reason. I don't know. It was sent to me from a manufacturer to play with. Just I utilize in classes that gives us a good idea of how to test the component.
And gee, I gotta ask, because I know a lot of guys are asking out there, and a lot of younger techs will follow that troubleshoot tree, and they'll give them a number, and if they're out just a little bit outside that number, they're just kind of stuck. You know, replacing a part that the trouble tree tells them is at fault, and they find out that guess what? It's really not, because of that small variance. The meter can be off that much, the leads can have an impact on that.
Very good.
Has it been your experience, and I'll even ask Pierre because of all his European experience, when you have an issue that the component has shorted, it's causing too much current draw through the module, is it really a matter of a tenth or two, or is it usually out there?
It's usually out there.
It's usually
It's usually a
Just
big
like
number.
Voltage drop. You know, we always talk about the specs for voltage drop being a 300 or whatever the individual instructor seems to favor. But when the reality is, if you have a problem with that, it stands out like a bull in a china shop. It's no question you have an issue. So even this did come in at 1.3, I probably wouldn't be as concerned. But if I start reading 5,
right.
there's a problem.
Though I'll say this, in the European stuff, they're very sensitive in their onboard diagnostics to small variations. So usually you'll end up with a code before you have a burn
Right.
with a small variation.
That's very good to bring up.
And if you didn't hear that, Pierre just commented that because of the tolerances in the software, in the onboard software on the Euros, you can get a code set for something that hasn't caused damage to the board yet, but because it's that smaller variance, it's going to set a code for that circuit issue.
No doubt. No doubt. Now, let's use the meter, and let me take some of this junk out of the way here. Let's use the meter and test the amperage because maybe some people don't own an amp clamp, right? But, and again, if you don't have the power probe, you can use jumper wires. I don't know why you would want to punish yourself, but let's say you don't have it. I'm going to take my meter lead and I'm going to go positive to the most positive, and I'm going to take my negative lead, and of course I'm in the meter, in amps, I'm going to go over to amps, I'm going to put hold on. I'm going to touch right here. I got continuity, right, Pete? Show them continuity first. You see his green light? Because my meter is in series. Series, the tip of this is going into the amp. The amp is coming up, coming down, going through, completing the circuit. Now when Pete hits this, give it a shot. 1.367. Can you get that, Pierre?
I sure do.
Now, wasn't that the same amount we just seen on the scope? Now, by the way, when you're using an amp clamp, and we could use the clamp, this one here, you know, we could take it and put it right into the meter with the ends and all that. You can use it off the meter in your millivolt scale. The thing is, you got to watch where the decimal is, okay? Because the decimal will kind of mess you up a little bit. If there's the little connectors in here, maybe we'll do that and show you. While I'm trying to find a connector, is there any questions out there? No questions?
We must be doing a really good job.
Either that or we bored them and they fell asleep. I don't know. I don't know where they put those little connectors they had. At any rate.
There's a request to repeat the test, though.
Repeat the test, okay.
Okay, I guess before we go into the mechanics of it, all we're doing is replacing the meter in series between the power probe tip and the EGR valve, where before we just had the power probe going directly to it. So we still have the same circuit, the current path is still the same, you know, from the power probe tip to the device, but now we just have the meter in series like you put any other ammeter.
Right. Maybe those wires would work here, one with the metal end sticking out. So look where we're at. In the meter, we're on amps, red lead, hooked up to the end of the power probe tip. The black is right here. What we're going to do now, you can do min-max if you want, or, you know. I'm going to put min-max this time. Go ahead, Pete. So we see we got 1.367, 1 amp, 367
There you go.
milliamps. And again, look at our leads in the meter. Red in the 10 amp, black in the common. The red tip going to the most positive of the power probe when he puts it on. The negative going to the other side. The black lead right here, maybe Pierre, get in on this. The black lead that's extra off the power probe, that's ground all the time, is completing this circuit. Completing the circuit. So now we'll show you a couple of more things here that you're probably familiar with, like, let's see what it is, baby. Let's do a fuel injector.
Oh, you have a question.
And on the fuel injector, Pete puts his lead right in here. He has continuity. But if he merely puts this on, he's not going to know how much amperage there's in there, right? So look at his hookup. Yeah, I can hold this side so you can see. We got continuity, but we don't know how much amperage it is. So what do we need to do? Well, we could do this two different ways, couldn't we? I could do this on the negative side, correct? But I'm hooked here, so I'm going to do this off the positive side. I'm going to take my meter lead that's going out, coming in. Does he have continuity? Let me hit the min-max again here. Let's watch with this. Can you get in on that string, or I got to tilt it?
No, we're good now.
Okay. Shoot it. And let's see what our max was. 767 milliamps. So this would not burn the computer out. Now, typically these are about 900 milliamps to 1 amp, but that means we have fuel pressure behind it, right? And that's a mechanical resistance that increases the pressure. Now, questions?
If you have a failed ECM, are you recommending that you check all solenoids?
Yes.
Yes.
Do you have no fault codes on every time, no matter what?
Okay, here's what I'm recommending. Now, my son, who's not here, argues with me about this as well. If you have a vehicle that comes in with a burnt PCM, the question was, am I saying to check all the solenoids? Yes. And look what you're looking at. You're looking at a wiring diagram that you're going to have to go through. How many solenoids do you think are in the PCM or BCM or whatever, tranny, PCM? Look at them. There may be 20 of them. There may be 30. It doesn't take long once you get the computer unbolted, take it off, and check in the solenoids. Again, that's why I wanted to show you that GM tool. I've done that for years. Now, sometimes you get lucky. What do I mean you get lucky? You put one in, it doesn't burn right away. Sort of like the old code 26 on GM quad driver code. Very, very common. They reset. Some of them are resettable breakers, but not all of them. When you start burning them out and you plugged in that most expensive fuse, the PCM, okay, you're going to do the same thing you did to that fuse. You're going to burn it out, and it's too late.
Yeah, how many times have you had a situation where you had a fuse, it was burned out, you put it in, and it didn't pop? Not today. You can have the same thing with a output or even an input. On the computer. That not today, because it's thermal damage. It has to be something that's a high current flow or excessive current flow over a period of time.
Right. Maybe when it's under a demand, whether it be cold, hot, whatever. It's just like your toaster at home. You know, your toaster starts blowing your circuit breaker, and then you break down and finally buy a new toaster. But you took so long to do it, it kept tripping the breaker, tripping the breaker. Now the breaker's weak. Sometimes even with that new toaster in there, that breaker is still going to blow because it's warm. So I would say, yes, that's what I do. And it doesn't take that long. You know that old saying that Son used to have, test, not guess. Unfortunately, too many people are going, let me put it in, that's it, or I know, you know, this component burns a lot on a car. Well, we got a brand new component here, and I'm going to show you how much amperage this is. I'm not putting my meter on it because it would pop my meter, okay? So, brand new, someone bolted this up and then they had it change the computer. This company's no longer in business, so I left the label on it.
I'm going to back up just one real quick step. Jeff, you can take your lamp clamp, but that plugs into your meter, right? You have the right ends on that?
No, he doesn't. That's the problem.
We don't have the ends.
Well, my bad. But I just want to point out that again, with many of these amp clamps use the same jack, so you can use, again, the little amp clamp instead of the meter if you want, and you can just clamp around the lead instead of having to put it in series like we were doing here. You know, maybe we can actually kind of show how this would be, like you did earlier.
Well, here's.
I'll unplug it for you.
We have one like this.
Yeah.
Now this one here is by General Technology Corporation, GTC. Good guys, great tool. Good. In fact, one of our innovation award for their coil on plug tool. Now we put this on amperage. We zero.
Yeah, where's the jack?
Oh, we'll do that fuel injector. I threw it back. We'll do it.
You threw it back and it was too small.
I just figured we'd get it out of the way so we wouldn't get all confused, you know? Okay, so now we're going to do the same thing here. Pete's going to go to one end. The other end, he wants to make sure he has continuity. See that green light? And now, the amp clamp, we're on the wire. Let me zero. Okay, go ahead. $747. Got to hold it down on this one. 743. Can you see that? This is a good quick check, by the way. Okay. Now, if this fits around for parasitic draw, that's great. Okay. But a lot of times the parasitic draw, you need to go around all the battery cables. This wouldn't be big enough. They do make a bigger one. They do make a bigger one. So that's this. Now, let's look at another component here and something I'd like you to build. This is a fused lead. So I could pop this, and I have one with a circuit breaker, but I don't know where it is right now, so I'm going to have to probably wind up popping this rather than popping our lead. We take this, we can go to one end in there, Pete.
What size fuse do you have in there, Jerry?
10 amps. We never want to go past what the meter has in it. If we do, we'll be buying a new fuse. So when Pete hooks this up and we go through and once he touches this, and does not go to the other side. You notice he has continuity again.
Your meter's on min-max. There you go.
So look, we're good here. We have continuity. Can you see that?
Yep.
The fuse 10 amp. Hit it, Pete, and hit it quick. Let me see what we got. Oh well. It went over range.
And that's a 10 amp over range. But again, let me stress the point. I didn't hear the fuse.
No,
I still have continuity. The fuse didn't blow. We definitely went over 10 amps.
I'm going to put this on, and I'm going to put its peak and hold on. I'm going to zero it. I'm going to put this around here. Shoot.
I heard the fuse pop that time.
Yeah, I think it did. Yeah, it didn't grab it. Oh well, once again, that's a 10 amp scale. And I think that fuse did go bye-bye.
Yeah. Now, just for giggles, you got another fuse to throw in there, or is it easily to grab one?
Maybe. Now, how do you know the fuse is blown? I have no continuity. Nothing.
I'm not 100% sure from the light here if this is or not, but we'll try it.
It's a mini. This is a real small fuse. But our fuse, believe me, is blown. Now,
again, with you scope guys,
notice my meter fuse is not blown. I blew an inexpensive fuse. I made this fuse holder, buy it from Napa, CarQuest, Rogo, Worth, whoever you like. Okay? Put a fuse in. I use a 10 amp circuit breaker most of the times, but I don't know where my other one is with my 10 amp circuit breaker. So I know I didn't blow this because that took the hit, and that's the thing to do.
yeah. And as a side note for you scope guys, that scope samples a whole lot faster than this little handheld unit might, and I'm very impressed that the Fluke sampled fast enough to catch that momentary key on. But you could hook up your scope and you'd have caught that because of the sample rate on most scopes. You'd have seen that peak. And just another reason too, when you're testing, that if you have a low amp clamp, that's the tool to use, because you're not going to blow anything, clamping around the wires. When you put that meter in danger, that you're going to start popping things.
Here's what I'm doing. I'm using my power probe, putting the amp meter right around there and putting it to my Fluke and catching everything. Sometimes we need to use power and ground if you can get in on the screen here. Can you get in good, or do I got to tilt the meter?
No, I got it.
Is that good?
Yep.
Okay. So, here's one way to do it if it's only on the ground side or only on the feed side. It could be going to the positive post of the battery or power probe, whatever, right? And connecting power to the other end, meaning the other end of the solenoid, solenoids have 2 wires, is being the ground, right? But in many cases, you're going to need the power probe and the lead. Why? Because when I disconnect the computer, I pull the computer out, here's my wires, the 12 volts that was going in to power up that evap solenoid, and the ground that went from here to the evap solenoid, well, if I put ground to the evap solenoid, it has no power, right? So what do I need to do? I need to find the spot that's going to get power, I need to find the other spot that's going to be ground, and I need to measure all this. Either with the meter, with an amp clamp, with something, right? That is pretty easy test to do. So, we went over a bunch of stuff, got a lot more to go, but we want to hear if you got some questions out there. Shoot.
If you get a burnt up ECU but don't know the cause, what is the best way to diagnose what caused it?
Okay. Question is, if you get a burnt ECU and you don't know what caused it, what's the best way to test it? Exactly really what we're telling you here.
Grab a schematic and the pinout diagram. If you disconnect that harness from the ECM, you can use the power probe as a great tool. Identify the ground for those components, whether they're ground driven or whether they're power driven, and you actually have to test each individual one. Now, let me ask you a question, G. We're talking a lot about the control devices, the outputs that we're in charge of. What about input, like maybe TPS? Have you seen instances where the power from the computer,
5-volt reference,
or even the power supply or ground supply to the sensor is shorted in the harness to power?
then you usually get a code with system voltage low, a short down. Now, if you have usually a 5-volt reference on an input down, if you fix that or disconnect that where that problem was, usually the 5-volt reference will come up because it goes with 12 volts, goes into the PCM to a 5-volt regulator, and then you'll be back up.
So I guess, I mean, to clarify that if you have a reference voltages being sent to a variety of sensors, then with everything up and functioning, you could actually check those for the presence of that reference.
Correct.
And make sure that that's where it's supposed to be in the correct, voltage level.
Right, now, another thing now, Power Probe has a new one out. I didn't have one in my hands, but I've always been asking him to, Bill and Jeff, the owner. Sorry, Jeff. I've been asking him to always put variable voltage in, but sometimes I'd like to dial in 5 volts.
5 volts, 8 volts.
8 volts, whatever, okay? His new one does that, also does amperage. So here it's pretty neat, but we'll see one, I'm sure, in the future. I'll see him in California real soon,
Another question?
When you're checking the resistance, is that with the power probe?
When we're checking the resistance, is that with the Power Probe? Well, in a way, this can be used to check continuity. Meaning, I have 2 wires, Pierre, can you get in on those pins there for a second? There's 2 pins in there, right? Now, with the 2 pins, I'm going to go in on one of them, blind as a bat. And I'm going to go in on the other side, and yes, I'm just going to have them tilted like this. I'm checking continuity. The green light, does everyone see that green light? That's only telling me that the windings are good. Okay? That one wire is going out to the 2 pins, and they're all hunky-dory.
I got to throw this in because this is something we talked about before. If you're going down a spec of resistances, to me that's just too open. You don't want to get caught where you're seeing a spec for, say, this component X is supposed to be 12 ohms and you measure 13 and you condemn the part. That's not the way it works. Your meter is going to have variance in it. If you a lot of meters are much better quality than others. If you look at the spec sheet that came with your meter, you're going to see what that variance possibility is. Temperature is going to be a factor. The age of the component can be a factor. Use the techniques we're showing you here. How much current is being drawn? What's the voltage drop in the circuits that you're testing? Use those. That's a much more accurate way to determine the resistance, if you will, than simple ohm meters.
Yeah, once you zero it, let's see what the resistance of this actually is. Yeah, you hold one, I'll hold the other. So we're checking resistance of this unit. We got not 1,000 ohms, not million ohms. You got 0.2 ohms. Very low resistance, so it's not a break. By the way, is there a reason why it's pulling like probably 15 amps or better? Low resistance equals high amperage. Now, this is a perfect thing to look at. Okay? Little relay here, right? You see the steel bar? Well, the steel bar is inside here, but you see the windings? When these windings get shorted, so let's say there's 100 strands, right? Strand 1 comes out of one terminal, strand 100 comes out of the other terminal, right? Let's say that strand 1 somehow shorts out to 25 or 50. The resistance is now lower, right? Lower resistance, higher amperage, smoke show on your computer.
Yeah, and then to stress here, just to clarify that for you guys, there's only one wire, but what G's referring to is the number of turns, the number of times that wire is going around that cord. So that first winding could be shorted halfway through the pack. So now instead of the wire being 100 feet long, it's now 50 feet long, and that changes the resistance of the wire. And I know you guys have more questions. I see the perturbed looks on your face as you see the screen.
Is there a good rule of thumb for the amount of parasitic draw that will drain the battery?
Parasitic draw Nowadays, look, anything more than 75 milliamps on a vehicle, and that's high. Most of these new ones are down somewhere 30 milliamps, maybe 40 milliamps, maybe 20. Some I've seen 15 on some Volvos. So I would say seat of the pants for a car, when I say today's car, a car late 90s, 2000 vehicles, I would say you're somewhere 50 milliamps or under. An older vehicle back from the 60s, you get away with 75 milliamps. That's for Parasitic oil.
But again, check your service information system.
Yeah, RTFB, read that book, man.
Yeah,
That's where the info's in it. Okay, next one.
Does lightning from a storm cause failures in ECM often?
Yes, does lightning,
Often?
well, not often, but does lightning, question is, does lightning from storms cause failure in ECMs often? I wouldn't say often, but it can do it. Now, the most important tool, in fact, we were just talking about this, the most important tool is the tools God gave us, your brain, your eyes, your ears, your nose, your hands. If you look at the antenna and you notice it's burnt and the paint is a little scarred up, hello, God has given you a big signal. You don't need any diagnostic tools, okay? It does happen, and thank you for the question. I'm not trying to be sarcastic, I'm just trying to say, look around. I do know one tech that did spend a lot of time checking stuff, and all you had to do was look. So, that's why I bring that up. Next question.
Is it true that some of the newer PCMs have internal protection for excessive amperage draw?
Is it true that some of the new PCMs have internal protection on the new ones there for the circuits? Yes, some of them do. Some of them are built a little bit different. But this is no different than years ago on those drivers that were resettable. They still burn.
Raise your hands out there in webcast land. Who among you has not forgotten to move the leads and seen the puff of smoke go up from a multimeter because you touched the leads in the wrong place at the wrong time? Is there internal protection in your meter? Yeah. Did you abuse and overuse the protection that is provided? Duh. So yes, sure, it can happen.
And again, when you buy some aftermarket parts, not all aftermarket parts are bad, please don't get me wrong. But you buy some poor quality stuff. There's a lot of junk coming in from Japan and here, not Japan, excuse me, China and other places. Well, guess what? You buy junk, it's probably going to be junk. And this could burn out the computer. If you know you're buying from the big guys, the Napas, the Carquest, the Whirlpacks, the OEs, they make good stuff. And you're not going to have a problem. Okay? And I also caution with a lot of coding of parts that you need to do. Okay, if you get something you have to code, like one that just came in the other day, a battery to code on a BMW. If you don't code it, whoa, that battery may be smoking for a while, right? So these are things that you need to know about and have the right equipment, the right information. Nothing more important than the right information source, right?
Especially nowadays. Again, the idea of rules of thumb, don't even think of that term anymore.
No, those days are gone. Next question, please.
What about any surges from jump starting other vehicles?
Oh, surges from jump starting other vehicles.
Sure.
You're stuck, I'm sorry, your ass is getting in my car because I ain't jump starting. Okay, jump starting could be a big problem. A battery pack or something called anti-zap. You know, Wreckmaster Towing is a whole training program that these guys go through in towing. Good tow companies are Wreckmaster certified. And they use all anti-zap, so even if they cross something, it's like a surge protector for your computer.
Sure.
And I would not recommend, the OEs don't even recommend charging the battery in the car without removing the cables.
Sure.
We had a guy on a bridge, jump start a BMW, had the explosive ends, and he arced it, and the end went poof. Now that car had to be towed off rather than just jump.
Yeah. Or reversing the cables accidentally, or performing a welding operation on the car with these electrical circuits intact.
I've seen a set of Michelin jumper cables that will not allow you to reverse polarity them. They have a box in them that corrects the polarity when you're jump starting and won't allow a surge through either. You can just tell them that.
Here, just pointing out that, that Michelin makes a set of cables, jumper cables that have a box on them where you can't hook them up backwards. You know, it won't allow it. You know, those are like trouble light or something?
Yeah, it's got a box on it with some circuitry. It'll correct it.
You'll know that you got hooked.
Well, it actually switches itself internally, so it's
I
right.
don't think the anti-sap does. I think the anti-sap just stops it and warns you.
Right.
That does. They make them in cables, little ends like I have inside, that you can put on the battery. I've had some crazy students, you know, trying to weld with it on there and not have a problem. I said, dude, you shouldn't be doing it.
Right.
Welding on a car, the batteries the main part. That's where everything's going to go for. It should be disconnected, you know, before you do damage and stuff. So please don't do that.
Good question.
What about jump box?
Jump box or jump packs, yeah, you can use them. They're a lot safer. A good quality one. You can't. A JNC over there is the jumper box is a real good one. There's a few good ones out there.
There's no magic in the jump box.
No.
The jump box is just a battery.
Yeah,
It just got a nice plastic case around it.
yeah, just a good setup that's a little safer. Next question. Don't be afraid to ask.
Well, this person would like to know what your go-to scan tool is nowadays.
Oh boy. The question
He wants to
was,
get me
what is
fired.
your go-to scan tool nowadays? You know what? There's
Depends on the car.
It depends on the car. There's no one perfect scan tool to use. But I tell you what, we have an increasing library of resources on the motor age community where community members have told about their own particular uses of a variety of tools. It's there for you to dig into and compare notes. And that's probably the best advice I can give anybody. That is look at what kind of cars you're working on. Talk to guys who are doing the same thing that you are. You know, see what they're using, what their opinions are.
And try not to skate through the question. Scan tools that we would use, it depends on the car. If it's a European car, probably the best scan tool, and this is just my opinion, not the opinion of Motor Age, the opinion of TST. You can watch our scan tool shootouts. In the European scan tool arena, AutoLogic, hands down, the best. Autoland Scientech, very good tool on European, on a lower level, we'd say, but does a good job. Also phenomenal on Asian. A lot of big companies and stores use them. I don't want to mention their name, get them in trouble, or just in case they get them in trouble. I like stuff like Snap-on and OTC, and I'm going to tell you why. Now, a lot of people, some people are on the red side, some are on the blue side. I'm going to give you, that's just like, hold on.
That's a political thing.
That political thing going on now? No, forget about it. Don't get me started with that.
But don't relay the red and blue to the red and blue that we're talking about.
We're talking scan tools here. I'm not talking Obamacare. Okay, at any rate, when we're talking about the scan tools, the reason why I like the red one, Snap-on with Troubleshooter, is it has Troubleshooter and it has a path for you to go so you can diagnose something in case you get a brain fart. We all do. OTC, super strong. I'm going to tell you why they're super strong. They're like one of the best kept secrets. They got Pathfinder, which is ungodly good, but most people never go through and use it. They got specifications that people can utilize there. They'll tell you some known good things for that car. And they got Identifix built into the tool. And that's really nice. Also, I know with my Pegasus, I had to look up because I hear all the names, but I do have the Pegasus. When I use that either by the laptop or the handheld, I'm online to Identifix. So you get the latest, it's one step better than the Genesis.
Yeah.
And by the way, if you have the Maco or Mac version, it's the same tool as the OTC. So those are some of them, and I'll even throw, for generic stuff, generic drivability, the eScan by ATS is a phenomenal tool for drivability, and probably for another PC-based tool that we seen that did very well in scan tool shootouts is the Auto Ingenuity. So there, we said the names. Pete didn't fire me yet. That's after we get off.
But that's a great resource. Just to put it out there, guys, visit the tstseminars.org site. Check their YouTube channel out. They do a lot of tool comparisons head-to-head on a car, and they say this one, on the same car, this will do this, and this tool will do that, and then you can form your own opinions. You know, what fits your budget, what fits your particular needs,
Right.
You know, what's going to provide you the return on your investment.
Next question before we get too
What
off
brand of scope are you using on your laptop computer?
That is the eScope Okay, the 8-channel, and he also makes a 4-channel, that is ATS, Automotive Test Solutions. Also, another good PC-based scope is Pico. Okay, we've used that in a webcast. I've used it quite a few times. You may tend to favor one over the other. That's just a matter of opinion. This scope has 2 time bases, so that's a big plus, and it also has a sensor simulator built in, which, by the way, sensor simulator, when I have a burnt out computer, I may be able to send a signal out to see if I can get it through all the wires and stuff, and see if the computer has logic. So, other questions? You're doing a great job there, girls.
How about memory saver plugged into the cigar lighter when replacing
Oh,
battery?
memory saver in the cigar lighter or a cigarette lighter is a no-no for me. Ordered ALDL, and I'll tell you why. The 16 cavity connector, did you check first that the fuse, the wire on 16 was actually good, that it had power going to it? If there's an open circuit there and you plugged in to keep the memory alive, it's no longer alive, is it?
Right.
I'm not a fan of that, and I don't like the cigarette lighter either because it could pop out.
Well, I think the biggest find you're going to find, if you take a look at, if you go to your service information system and you look at the power distribution diagram, which is the general diagram that tells you where everybody gets their juice from, you're going to find that on most modern cars, the cigarette lighter does not supply power to all the modules. It might serve the ECM, but it's not going to serve the other 42 that are on the car. So if you connect the box to the diagnostic link connector, now you can be sure that you're going to get power to everybody at that one connection to keep them alive.
If we don't have it open.
Right, if there's not already existing problem.
Now, the other thing you can do, which I like even better, is go to the alternator B+ wire, use an external battery or battery pack, make sure it's good, and go to the positive side, of the alternator and the ground of it, and you're powering everything up.
But keep in mind, when you take that battery loose, the leads are hot because you are supplying power through another source.
No doubt. And if you got a big battery doing it, you got a lot of power, and so the current.
Just make sure you're using some caution when you have that positive battery cable dangling in the air.
Okay, other questions before we move on? Okay, good. We're getting through. So again, to review here, when we unplug the wires from the PCM, that would be here. If it needs power and ground, we can do that. We can use an amp clamp, we can use a meter, it doesn't matter. Let's look at a couple of other tests here, like a fuel pump. This is a real fuel pump out of a car that they took out. We're going to run this thing.
This is a Geo.
Yeah, look at a burnt terminal. It's a GM pump, actually.
Really?
Yeah, E6. Yeah.
I said, look at 2 little teeth.
Yeah, look at the burn marks on the terminal.
Oh my gosh.
Little smoke shot. By the way, we just had a car come back that the wiring, and I won't mention the fuel pump company name, but a major brand that supplies OEs, the connection here wasn't good. There was a voltage drop on it, causing the vehicle to get intermittent stall every once in a while. A real bear to figure it out.
Well, our next webcast is going to provide some help.
Oh yeah, we got a good webcast coming up with Federal Mobile. Right?
Yes, sir.
Federal Mobile. Okay, so we got continuity here. We could run this, but we don't know what the amperage is. So we're going to use the trusty amp clamp from the scope now, because we want to see some good waveforms. I'm going to put the scope on. Remember, I put it on, I zero it. And here, just get in on this. I want to make sure I'm on the best resolution. Okay. Zero it. I'm going to put it around the wire over here. And watch the amperage. Now this pump is pretty worn. You can even hear it. It's probably hard for you to see. I'm going to change the time base, Pete, if you can hit that button. If you can hit that.
Oh yeah.
Okay, let me get over here. Change the time base. Speed it up a little bit. If you can zap it across. Okay, so there's our humps. Oops, I went a little too much. There's our humps, but look at our amperage. Very low. Not surprising that this pump, and by the way, you know, I bring this to a lot of classes, so I can tell you, this pump has seen some better days. One of the things we'll be using, I think we've done in a webcast even prior, we're going to have pumps that are actually in a special tester, so you can see what they're doing. This one, if you run it dry as many times as I did, all the impellers in there, they're pretty well worn out, right? The armature's pretty well shot. So So that's pretty easy to test that, right? Do we want to see what that amperage is locked on the scope
Yeah, sure.
for that? I mean, we'll only pop this 8 amp breaker, so you will play the man of putting it on, and I will try to capture this. Let me know when you're ready.
I'm set.
Shoot. Whoa, we went off the scale. I got to go to the higher scale. We blew way up there. Okay, let's try it one more time.
Ready?
Yep. That's over 20 amps. I'm going to go to the next scale. Here, can they see that?
Yep, we got it.
Okay, so I'm going to release this and I'm going to go up to 50. By the way, that's why that component burnt the computer out. And you know what the shop did? There's no lie. They replaced 3 computers before they brought the car to me. The new part can't be bad, could it? That's why you got to test a new component. Let's do it again, Pete. There we go. 21.19 amps. So this thing fried a freaking computer. Soon as the guy turned it on and the IAC motor wanted to move, fry city.
Yeah.
And merely throwing another computer in is not going to solve your problem. Here's what I do, and this is no BS. I'll test something because my power probe, I can take something out real quick and go, let's take this motor right here, right? I can take this thing out and hook an amp clamp like this up, just for a quickie, stick it around. Oops, sorry. Be not down far. Give me 1 second here.
While G's setting that up, I mean, you can make yourself some little jumpers for things like this.
Yeah, we have to have
Just be sure that when you're doing that, that you use the correct end for the terminal. You don't want to damage the terminal, you know, in the process. A lot of these low current devices, that alone will cause them a voltage drop issue to make the component not work.
Can you maybe just hold that amp clamp up? This is an old idle stepper motor. Well, maybe hold it up so you can see the amperage on the meter. Can you see what it's reading? Like 100 something?
Yeah, about 110, 115 milliamps.
So that's practically nothing. Now, I want to apply physical resistance. I'm going to hold this piece right here with my finger. Okay. And when I do that, watch what's going to happen. Oh, I went in the other way. I have to reverse it. It's a reversible DC motor.
The joys of live webcast, ladies and gentlemen.
Just going to say that.
I'm just too lazy to put the wire in there. Okay, now, look at the amperage now.
Yeah, that's nearly half an amp. 450.
Now I'm going to let go of it. How about now?
Now
500 and
we're
something.
over half an
Now, where did it go? Went down.
Now it dropped, gosh, down to nothing.
Okay, so physical resistance, so something binding up where something can't come out will make amperage come up as well and burn the computer out.
Sure.
Now, we're checking all these components right here. You can do this by disconnecting the wire from the connectors from the computer and checking everything from there. Nothing better. Why? I've come across some vans where the wire for the fuel injector grounded. Okay? Well, you start going through there and see why this injector had gazillion pulse width on. You can find that maybe you had a wire shortage. When the wire is disconnected, I can even disconnect it off the component, apply power. If my 8 amp breaker blows, you know what that tells me? There's a short to ground. I got a direct short. Alex here did one job on a Honda one time that the guy started jerking around on his car, burnt up 3 main harnesses in the vehicle, and even going to the back of the car. I mean, this thing was a mess. I told him, I said, look, Alex, you gotta check all those wires because one of them is probably short and pulling this whole thing down. He fixed it. Sometimes it's simple, basic things, and then understanding, reading up on how something works. So you don't have to get too technical and be Von Braun and go to the moon, but understanding how things operate and how to test them. Okay.
And again, we're not telling you anything that's high tech here. These are very basic tests. It's just taking the time to perform those tests so that you don't put 3 computers on the card. You start looking at the box going like, well, boy, this is
something's got to be wrong.
This is a cheap part. You know, what a piece of junk this is.
Oh, by the way, they always say, you know, the red one sucks, the blue one's worse. You know, everyone's stupid, but the guy who's doing the big mistake. So don't be a person that's going to make a mistake. We all make mistakes. We've all did a smoke show. If you didn't, you're not a real mechanic. Because I got to tell you, I screwed up over the years. Touch something wrong, you go, oh, God. Now you got to buy the customer a computer or whatever. So look, it happens, but we're giving you shortcuts that at least I wasn't taught years back. I learned from the hard way. And you know, Motor Age and PSD, we're here to provide technicians with that help. Let's go through some questions.
What is the most amps on motor?
What's the most amps, if he's talking about on these types, what type of motor? If this type of motor or anything that is connected to a PCM, we really do not want more than 1.2 amps for 6 milliseconds. If it goes over more than 6 milliseconds and you're pulling 1.2 amps, you're going to burn the driver out in the computer.
You got to look at the wiring. If it's like a fuel pump that's run by the computer, they usually have a relay or some other control.
Right.
That's a good point. If you look at a lot of the devices, like say, let's just take a fuel pump for example, as Pierre just pointed out, they're going to draw more current. But those are generally controlled via a relay. That's to protect that computer from that excessive current.
That's why we have the low side, the 30 and 87, hot 30, 87 load, but you have controls like the 85, 86. That's the part the computer's controlling. Now, do relays go bad? Yeah. Could you buy some cheap relay that looks just like the other relay and cause a problem? Sure.
Well, let's just talk about that for a minute. I have a fuel pump relay or a fuel pump or a very, very common air conditioning clutch coil. Cycles on and off. Well, there's current flowing through that coil. And there's a magnetic field around that coil. That's what closes that clutch up. What happens when that magnetic field, the power is turned off? What happens? The field collapses and it creates an induced voltage, just like an ignition coil.
No doubt.
So that's got to go back somewhere. If you look at the schematic, often you'll see a one-way diode right there wired at the compressor to suppress that voltage spike. Sometimes it's in the relay to suppress that voltage spike. So if you plug in the wrong relay, it doesn't have that protection. Where's that spike going? And again, we don't have to hit that computer hard for a millisecond. It may not hurt it today, but when that continues, I mean, on a hot summer day, that compressor's cycling on and off, and that spike keeps hitting that same spot. It's just like water running through the Grand Canyon. It erodes and erodes, and finally, it's going to give way.
Very good. Now we have time for a few more questions before we have to kind of move on and then wrap it up.
What is the sample rate per channel in your scope?
Oh, there's different sample rates on there. What I had it on, I don't even know looking at it, but it doesn't matter what the sample rate is, because I know this goes on to some things on.
It's pretty darn fast.
And it's good. We're gonna leave it. We're gonna leave it at that. I would say if you want more information about the scope we were using, visit automotivetestsolution.com.
Yes.
We don't want to get into. We said Pico is a good scope too.
Yes.
We don't get into P wars per se. So we're going to leave it at that.
Even many of the handheld scopes that some manufacturers offer are more than sufficient for daily automotive use.
If you have one of the old Intero units, it still captures a whole bunch of good stuff.
Yeah.
You know, there's plenty of good scopes.
The only bad scope is the ones gathering dust in your toolbox.
Oh, there's loads of that. What else?
Can a battery that is starting the car okay cause the EMC to go into limp mode?
Yes.
Yeah.
And what you're referring to is that when you hit that starter, you're putting a tremendous load on that battery, and the system voltage can drop below
That
the
9
threshold that the
true.
ECM needs to keep going. You can actually reset cam, You can throw off throttle bodies. I mean, a lot of weird things can happen. I know Chrysler, I had a lot of issues with Chrysler.
Yes, and a lot of issues with a battery that'll start the car,
Yes.
and monitors will not run because that battery's too weak. The alternator keeps trying to charge that battery up, and the monitors will go into
So
suspend.
certainly that's an issue. If you have an electrical issue, one of the very first things you're doing is checking the health of your battery.
Yeah, the battery is the whole shooting match. And by the way, make sure you get the right rated battery. People like putting 1,000 CCA in. The higher your CCA, your reserve capacity drops, and then you run into some problems. And if it's a glass mat battery, use the right battery. Don't go putting some just wet cell battery in. Any other questions?
If you had a Dodge PCM where the 5V reference was no longer coming out of the PCM, would you start checking every 5V reference sensor?
Okay, so if I had a Dodge where I had 5-volt reference not working anymore, would I check the rest of the 5-volt reference? Yeah. You probably have something pulling it down. 5-volt reference could be MAP, coolant, intake. Something could be shorted, bringing the 5-volt reference down.
You can't back probe the ECM and see the references there and think that's okay, because you're not going to, it's like you said, it's being pulled down. The best thing to do is to check your schematics, see what sensors are receiving that reference, and start unplugging them one by one while you're monitoring that voltage. Once you see it come back, you know that last sensor you disconnected is the one that's shorted internally causing the problem.
And what kind of time would you charge for that?
Well, we can't get in to say what type of charge time. I mean, it's a good question, what type of time.
It's a good question.
But look, there's nothing in the book. I used to have a set type of diagnostic time. You need to make one up for your shop because, again, we can't get into telling you what to charge. There's some rules and regulations on that, unfortunately.
All right. How do you feel about the Power Probe hook for this?
The Power Probe hook, I don't have one. I'm sure my buddy Jeff, this thing kicks butt. If it's, I love this and I had the original one. I'm sure the Power Probe hook is going to be off the hook. It's going to be killer. So we look forward to actually having Jeff, who's going to be on our last TST roundtable. He was stuck in production of a video. So I'm sure Jeff in the near future will be our TST roundtable guest. You will get to see and hear all about the tool. And this is the last question before we have to move on.
Can a short from anywhere pull down 12 volt from a DLC?
A short anywhere pull a 12 volt
If you're looking at pin 16, if that's what you're referring to, then I would have to say no, because that's like any other feed wire in the car.
It's gonna pop.
That's its own circuit, and you should be able again to pull the schematic and trace that circuit for the fault.
Yeah. Sometimes there's wiring that has been cut or something like, again, when they're on the cigarette lighter, someone drops something in there and shorted power to ground, pops the fuse.
Yeah.
Okay. Let's look at the rest of this. We only have a few minutes left with you. Here, that most expensive fuse, we can do all the checking of these components. Please, remember this, that output control. So anything, coils, IAC motors, relays, fuel pumps, coils, injectors, any solenoid, evap solenoids, EGR, all of them. Use caution when replacing PCMs. They don't just happen to burn out. There's sensitive circuits inside the PCM that are easily damaged by actuators that have been shorted out. Now, that's not to say you won't come across some Mitsubishis, some real old GMs that had some sort of problems that just went, the board heated up. You know, some of them we used to tap on because they had a problem. But I'm saying the majority of what we're looking at when I get problem vehicles is someone is not looking at those output controls, those solenoids. So use proper diagnostic procedures to test all solenoids before replacing the PCM, TCM, BCM, whatever. Damage to the PCMs are commonly caused by shorted solenoids or a solenoid that is binding somehow. You know, you get a lot of these, Pete mentioned earlier, we had an evap webcast we did. Well, some of those solenoids you need to test many times, and if you put a vacuum pump on them, you'll see sometimes it won't hold, it'll drop because they tend to stick. They don't always do them right away, and they'll burn some stuff up. This is important. Low resistance equals high amperage, and we're talking electrical resistance. Low electrical resistance equals high amperage. So that being said, We want to again remind you about our upcoming TST events. You can go to our website, click on there, and webcast, you got on it, seminars, our YouTube channel. We will be up in Massachusetts, September 10th, 11th, 12th, and 13th. The 10th, Massachusetts, 11th, Connecticut, 12th in Totowa, New Jersey, and the 13th here in New York, and simulcast. This is a 3.5-hour webcast and seminar. Our roundtables are always free. September the 20th on that. The 29th, the California big event. Another roundtable in October. A BMW scan tool shootout. So we are doing this one. We'll use the factory tool, and we will use a bunch of other tools. If you happen to work for a scan tool company, you want to make sure we have your latest software. And no, we don't read any directions. It should be intuitive enough. We do exactly what the guys do out there. You should put it on, you should be able to work, and a lot of scan tools have done very well with that. November 12th, 13th, 14th, and 15th, the 3 hows. It works, the diagnose, the fix. Our buddy Peter Orlando will be out with that. November 20th, Carter Fuel Pump. That'll be here with Motor Age. So get ready for that good webcast coming up, and another roundtable, and of course we always have a bunch more. If you're interested in more training, here's where we're at. That's how I make money. So if you happen to get some techs out there that like some training, I come to you, or you can come to me. Pete, the rest is for you. Don't forget your after hours. Give yourself a plug.
Oh yeah, if you want to join in with me August 24th on after hours, it's I jokingly referring to that as the Tonight Show for techs. Similar to TST's roundtable, I have guests that come on, experts in a variety of fields. On the 24th, I'm going to welcome Joe Glassford from BestTest.com. Over 30 years as a teacher, automotive instructor, very good in electrical diagnostics. We're going to talk about electrical testing tips, and he'll share some tips with you. And I just got to interject something. Gene mentioned kidding about his primary business. Once again, I got to point out that the partnership between Motor Age and TST, these guys aren't getting paid to hang out with us. The ladies working the computers aren't getting paid to hang out with us and bring this information to you. They're all doing it because they have that motivation to help you, because they all do what you do. They're all working in the field. Many of them are still running shops of their own or working in shops. You know, they're just like you guys. So make sure that you check out their website, check out some of the offerings that they have, because they'll help you just like we're trying to do.
And one last thing, we have our buddy from Philadelphia coming up to teach out on Long Island.
Oh yeah, Jim Morton, yeah.
Our buddy Jim Morton's going to be out there. I forget the date, but if you're interested, you can email us at TST and I'll send you a flyer along. Long Island group, the teacher out there is, and I forgot his name, but we did mention it on a roundtable. If you want more information, it's sometime, I believe, in September, October?
September.
I think September. So the 15th of September, because I know him around, I'm back.
Yeah.
So I'll be out there as well, and my buddy Jim Morton. Check him out, he's doing a full day class. And once again,
before we say goodnight, I gotta say one thing too. Mitch Schneider, happy birthday,
happy
buddy!
birthday, Mitch! And by the way, Mitch, when I'm out in California, you better come by to see us. We expect you at the big event. Anyway, good night from New York with Pete Meier from Motor Age, and our buddy Neil there in the back, who brought up the car, kindly drove all the way up, and Pierre and Doreen and Knock. Good night. Have a great one. Good range.